Hey everyone, welcome to lesson 2.3 on stretches. So this is the last lesson of Unit 2. For stretches, all x values or y values are multiplied by a scale factor, or that just means a number. So if it's a vertical stretch, you're multiplying all the y values. If it's a horizontal stretch, you're multiplying all of the x values. And here's how they show up in equations. So again, like always, the vertical is outside the function, so it's going to be out front. And we're multiplying by a number out front. So if we're multiplying by a number like 10 out here, it would be a vertical stretch by 10. And to do a vertical stretch, you're going to multiply all the y's by whatever number this is. So if this was 10, I would multiply them all by 10. If it was 30, I would multiply them all by 30. In this case, we'll say by a. Okay, horizontal stretches show up inside the function. So this b, which is inside the function, that's our horizontal stretch. And whatever this b value is, that's our scale factor, so that's what we multiply by. So in this case, we're going to multiply all of the x values by our scale factor of b. Okay, and it's a little weird. It shows up in the equation as division by b, but when we do the stretch, we multiply by b, so it's a little bit opposite. Okay, so let's go through the routine. We're going to look at some equations, and then we're going to look at some graphs. So first, let's just identify the stretches. So for the first equation, we have a stretch that's outside. So that means it's a vertical stretch. And it's by a factor of 8. So we would multiply all the y values by 8 to do this stretch. For our next one, we have our scale factor inside the function. Since it's inside, it's going to be a horizontal stretch. And it's by 12. So if we were doing this stretch, we would multiply all the x values by 12. Our next one has two stretches. We have a vertical by 20, that's outside, and a horizontal by 5, that's the inside. Okay, cool. So now let's try writing equations. We're going to start with our base equation, y equals x squared, and we're going to stretch it horizontally by a factor of 6. So this is going to be inside the function. So y equals, we want to be inside our squaring function, and to do a horizontal stretch, we divide by the scale factor inside. Our scale factor is 6, so we're going to do x divided by 6 on the inside of our function, and that gives us the horizontal stretch. I know that seems weird to divide by the scale factor, but that's just the way that it works. Okay, one more. So we have square root of x, and we're going to stretch vertically by 18 and horizontally by 2. So remember, the vertical is outside, and that's multiplication, and the horizontal is inside, and it's division. Okay, so y equals, outside we have our vertical scale factor, which is 18, and then inside we have our horizontal scale factor, which is 2. So outside the function we have times 18, inside the function we have divided by 2. So this gives us the vertical stretch of 18, this gives us the horizontal stretch of 2. All right, so now we'll do a couple graphing examples. Oh, this should say stretches, not translations. Okay, we're going to identify the stretches, and then we're going to graph using our parent that's shown. So for this one, our stretch is a horizontal by 2, right? So we're going to multiply x values. Okay, so let's see how this works. Start in the middle. The x value at this point is 0. 0 times 2 is still 0, so that point stays where it is. Now let's look at this point. The x value at this point is 1, right? We're at x equal to 1. I'm going to multiply that by 2, and I get my new point has an x value of 2. So I'm going to keep the y value the same and move that point out to an x value of 2. Now let's look at this one. This is starting with an x value of 2. If I multiply that by 2, I get 4. So that point moves out to an x value of 4. This point starts with an x value of 3. If I multiply that by 2, I get 6. So it moves out to an x value of 6. And then this side is going to be the same except negative. So this starts at -1, multiply it by 2 to get -2. This starts at -2, multiply by 2 to get -4. This starts at -3. If we multiply by 2, we get -6. Okay, so those are our new points, and if we connect them, we see that we have the shape of the original graph, but it's been stretched to the side. It's like we took it and we pulled it side to side. So we like kind of pulled it apart horizontally or stretched it horizontally. Okay, so that's how you do a horizontal stretch. Now let's look at a vertical stretch. So here we have a 4 multiplying outside the function. So that's a vertical stretch by 4. So we're going to multiply y values, right? By 4. Okay, so we start here. That point has a y value of 0. If we multiply that by 4, we still get 0, so we're going to stay at 0. This point has a y value of 1. We're at 1 on the y. If I multiply that by 4, we get a new y value of 4. So 1, 2, 3. The new point is there. We keep the x the same, we stretch the y up. This point has a y value of 2. So we're going to multiply that by 4, and the new y value is 8. This point starts with a y value of 3. If we multiply that by 4, we get a new y value of 12, which falls off our graph, but it would be like about there. Okay, so now if we connect these, we see that we have the same basic shape as the original function, but it's like we took it and pulled it up, right? We stretched it vertically, made it taller. Okay, so that's how you do a vertical stretch. Okay, now let's look at starting with some graphs and seeing if we can write equations for them. So this v shape, the parent function is absolute value of x. So we're going to start there, and let's see if we can figure out what the stretch is. So let's say I want to compare this point and this point. They're at the same y value, so the y didn't change, so we didn't stretch vertically. This point had an x value of 1, and its new point has an x value of 1, 2, 3, 4, 5. Okay, and let's see if that holds. Now let's compare this one and this one. Again, the y's are the same, so we haven't stretched vertically at all. This had an x value of 2, and this one has an x value of 2, 3, 4, 10. So 1 to 5, 2 to 10. So it looks like we're multiplying horizontally by 5. So I took the x values and I multiplied them by 5, right? 1 times 5 is 5, 2 times 5 is 10. So our stretch is horizontal by 5. And the way we put that in an equation is division inside the function, right? So y equals, we want to go inside the function, and then we're going to divide x by our scale factor of 5. So that's what a horizontal stretch by 5 looks like in the equation. Okay, one more. So this one's tricky because there's 2 stretches. Here's the parent, and let's pick some points to compare. So let's look at these 2 points. So the x value was 1, and now it's 1, 2, 3, 4. So we've multiplied by 4. Okay, and then the y value was 1, and now it's 2. So we started at 1 and went up to 2. So times 4 on the x times 2 on the y. So what we have is we have a horizontal stretch by 4 and a vertical stretch by 2. So we multiplied by 4 horizontally and by 2 vertically. Here, 2 vertically. Okay, and I didn't write down the parent function. The parent function for this shape, this kind of like squiggly shape, is y equals x to the third. Okay, so to do the vertical stretch, we need a times 2 outside the function. So before we do anything, we're going to multiply by 2. And then the horizontal stretch by 4 is division inside the function. So inside that cube, we're going to have x divided by 4, all on the inside of the third power. Okay, so this gives us our vertical stretch of 2. This gives us the horizontal stretch of 4. And that's what you guys need to know about stretches.